Hey everybody, welcome back. Today, Chapter 1, Lesson 3, Integers and Absolute Value. I hope you're ready to go, cause let's get started. Alright, so the very first thing, you have your warm-ups. Make sure you're doing all four here. And all you're doing is answering the problem. Give these a shot. Go! Pause now. Alright, so looking at these, we're evaluating each expression. They give us the values of the variables, which means we know what to do with it. Okay, very first thing we have to do with this x and the 17, we need to plug it in. Same thing with this y and the 6. We need to plug it in right there. Okay, so when we do that, we end up with 2 times 17 minus, not plus, minus 3 times 6. When you multiply those together, you end up with 34 minus 18 and our overall answer of, you got it, 16. Fantastic. Same thing with number 2. Again, plug in what we know. Well, we know that x is 3. We know that y is 2. Plug in what we know. That goes right there. Alright, so now we have 5 times, plugging in that 3 plus 3, because our x is equal to 3, plus 4 times 2. Alright, what is the very first thing we have to do? Order of operations state, we have to add. We have to add those parentheses. Sorry, not adding, but we have to finish those parentheses. So we get 5 times 6 plus 4 times 2. By multiplying and then adding together, we get 30 plus 8. Our answer is 38. Fantastic. Ooh, number 3, we get to deal with some decimals. Woohoo! Here we go. Alright, so we have 6.9 times the difference of x minus x and 2.7 plus 7.1. So what we are going to do, again, we have to take that x and we have to substitute it in, or take the 5.1 and substitute it in for x in the problem. So let's get it going. So we have 6.9 times 5.1 minus 2.7, and we're adding 7.1 there. Okay, so when we plug all, or very first thing after we plug it in is we have to do our parentheses. So we have 5.1 minus 2.7. What is 5.1 minus 2.7? You got it, 2.4. Then we have 6.9 times 2.4 plus 7.1. So we have to take 6.9 times 2.4. What do you get? 16.56. Adding 7.1, we have a final answer. Our final answer is 23.66. Whoa, that is an ugly 3. Let's try that again. 23.66. Much better. Look at those colors. Blue, we have red, we have black. Just makes math glorious, doesn't it? Glad you're smiling and enjoying those colors. Alright, last but not least, we have number 4. Okay, when we look at number 4, we are going to have 5x minus 4y. 4x is equal to 0.3. And y is equal to 0.2. Just like we've done in the previous problems, x goes in for x, y goes in for y, and you solve. So you have 5 times 0.3 minus 4 times 0.2. 5 times 0.3, you end up with 1.5, minus 4 times 0.8, we get, 4 times 0.2, we get 0.8. Subtracting those, we end up with 0.7. So 7/10 is going to be our answer for number 4. So if you remembered, 16 for number 1, we had 38 for number 2, 23.66 for number 3, and number 4 is 0.7 or 7/10. Fantastic. All right, now let's get going. Today we are going to be comparing and ordering integers, but we are also going to be evaluating expressions with absolute value. We have to learn about absolute value. Now we get to, lucky you. So let's get to it. There's some vocab words for you. All right, so the very first two is integers and opposites. Integers and opposites. So pause the video and I will explain these in a moment. Pause now. All right, so we have integers. What integers are, they're the set of whole numbers and their opposites. Okay, and what an opposite is, it is a numbers that are on the same distance from 0, but on the opposite sides of 0 on the number line. Okay, what in the world did we just say? Basically, integers are going to be positive and negative numbers, both positive and negative whole numbers. That's very key, whole numbers. So something like if you have -8, -8 is an integer. The 132 is an integer. A -1924 is an integer. However, when you start dealing with decimal points, you start dealing with fractions. Decimal points and fractions are not integers because they are not whole numbers. It's very key that you understand that an integer are all the positive and negative whole numbers. Opposites. Opposites, the other words that you will need to know is additive inverse. Additive inverse. So you may see find the opposite or find the additive inverse. All that means is if I give you a number of -9, the opposite, so we have opposite over here, the opposite of -9 is a +9. Okay, it's the exact opposite, same distance from 0. Those are 9 notches from 0, but they are opposite. One is positive, the opposite is negative. Okay, so if I give you the number 14, the opposite of +14 is a -14. Okay, let's say -132. Opposite of -132, +132. Okay, so integers are your positive and negative whole numbers. Opposites are on the opposite side of that 0 on the number line. Same distance from 0, opposite sign. Okay, awesome. Okay, now this is very key. I want you to remember this. You don't have to write this down. Numbers on a number line increase in value as you move from left to right. So on our number line, if I started on that very far left, if I started with 0 on a number line from left to right, I'd just mark it 0, 1, 2, 3, 4, 5, 6, 7. Okay, on the far left is my lower numbers, far right is my higher numbers. Okay, highest numbers to the right, lower numbers to the left. Now let's say what's to the left of 0? Well, we have -1. What's to the left of -1? We would have -2, then -3, so on and so forth. So as you look at this number line, a number line is a mirror of itself, with 0 being right in the middle. Okay, because 1 and -1 are one spot away from 0. 2 and -2, 2 spots away from 0. They're almost mirrors of each other, with one being positive, one being negative. All right, so let's try a few problems. Do you have to write this down? I am nodding my head yes right now. So I hope you're nodding your head yes right now, or saying yes in your head, or if you're in your living room, saying yes out loud. Okay, so write this down, and then we're going to talk about this momentarily. So pause now. All right, so when I look at this, what do these signs mean? We haven't talked about those signs, but what are those signs? Well, we know what an equal sign is. That far right is an equal sign. The other two are less than and greater than. Less than points to the left, greater than points to the right. So this right here is going to be less than, which makes the other one greater than. So what we have to do here is we are going to be using those three symbols to compare scores. Okay, and we're talking about a golf game here. So if I look at 4 and -1, which one is less than, which one is greater than? Okay, if you think you know how to do this, I want you to write a less than or greater than or an inequality sentence, and I also want you to graph it. Okay, if you know what I'm talking about, you can pause now, give it a shot. If not, I'll talk about it in just a second. Go ahead. All right. So if you look at Aaron's score and Felicity's score, if we looked on a number line, this is how I want you to look at this just like a number line. So you have your number line written down. Aaron's score received a 4. Okay, so we have a 4 there. That's on a point. That's how I graph the point 4. Felicity's score is a -1. Again, I just graphed -1. Right at that point is the graph of -1. Okay, now, what did we just talk about? The smaller numbers are from our which way? To the left or to the right? Yeah, to the left. Absolutely. To the left, to the left. Okay, I could sing that song, but I don't want to right now. All right, but we need the smaller numbers are to the left. So if you look at -1, -1 is to the left of 4, which means -1 is smaller than 4. -1 is less than 4. So if I wrote this, -1, then we need our less than sign, is less than 4. Okay, -1 is less than 4, and we can prove that by showing that above graph. Okay, so you graph your points, and then you write an inequality sentence, which is -1 is less than 4. That's an inequality sentence. All right, so let's try this next one. Okay, so you don't have to rewrite this section because that's what you wrote in the very first one, but make sure that you're rewriting this and using a new number line. All right, so I want you to try to see, you're going to list them from lowest to highest on the number line, and then list them from lowest to highest just in its own sentence. Okay, so give this one a shot. Pause now. All right, so if I look at this, the very first thing I'm going to do is I'm going to graph my points. All right, I'm going to start with -4. Graph -4 on my number line. Graph 2 on my number line. Then I'm going to move to 5. Graph 5 on my number line. And last but not least, -3 on my number line. So if I read this like I would read a book from left to right, I'm ordering from lowest to highest. So I need to read it from left to right. I would get -4, -3, 2, and 5. Lowest to highest. -4 is my lowest, -3 is my highest. Or sorry, -3 is my lowest. And the reason behind that is -4 is the farthest to the left and +5 is the farthest to the right with these 4 numbers. All right? Sweet. Awesome. Next. Okay, I want you to do the same thing, least to greatest. Order them now. Pause. All right, so if I look at this, again, if I were to draw my number line, just like that, wow, just appears. Man, I'm fast. Okay, so if you look at this, we draw our number line, and we plug this in by plugging in the numbers of graphing 8, graphing -5, and graphing 4. Which way do we read it? From least to greatest, left to right, smallest on the left. We go -5, 4, 8. Now, you might be thinking, Mr. Sheeman, do I have to use a number line? On the first few problems, yes, I want you to use a number line just so you get used to using a number line and graphing on a number line. Not just for ordering them from least to greatest, but just practicing on a number line, because we're going to be using number lines later on in this class, and I want you to make sure that you can graph a number line and be able to write correctly a number line down. Okay, so first couple, yes. If you don't need it towards the end of your assignment or towards the end of this lesson, don't worry about it. All right, But yes, I want you to make sure that you have this number line written down. All right? Thank you! Next. Now, we have absolute value. Okay, so I'm going to discuss absolute value in just a moment. I want you to pause the video, write all of this down, and then we will talk. So pause right now. All right, so absolute value. Absolute value is a distance. Okay, if you notice, it says right here, a number's distance away from 0. Okay, absolute value is always positive. If you look at this, the absolute value of -4, notice those two dividers there, those two black dividers. That is absolute value. Okay, this 4 is actually supposed to be right here, 4 units. Okay, if we look at this, all right, absolute value is always positive. And the reason behind that is absolute value is a distance. If I drive, let's say I drive from my house to Hill Murray. I'm driving 15 miles. From my house to Hill Murray is 15 miles. Here I am in my little car. So there's the Mr. Sheeman mobile right there, and I'm driving 15 miles to Hill Murray. Now, when I drive back to my house, okay, I'm driving back now. If I start driving back this way, do I go -15 miles back home? No, I don't travel a negative distance. I go a positive 15 miles back from my home. So how far did I travel so far to go from my house to Hill Murray, from Hill Murray to my house? 30 miles, right? Because it's 15 miles each way. All right, be careful because you don't want to get used to seeing distance as a negative number. If you look at has anybody had those watches for walking counting? They're counting the steps you have. If you have parents like that, if your parent starts walking backwards, that number still keeps going up. It doesn't go reverse. It doesn't go negative steps. Okay? Because distance is always positive. If you look at these bars also, these are dividers. That would be called the absolute value of -4. All right? So anything inside those dividers is positive. Anything inside those dividers is positive. Okay? Inside. Questions? Concerns? Otherwise. Sweet. Okay, so now we're finding the additive inverse. Additive inverse. We've talked about additive inverse earlier in this video. You should have written those two words down. What is another word for additive inverse? I want you to yell it out. Say it out loud so I can hear it right now. Say it out loud. Opposite. Opposite. Yes. Okay, so you are finding the additive inverse or opposite. The additive inverse of each integer. So pause now, give this one a shot. All right, additive inverse. We're looking for the opposite. Here we go. So the opposite of 6 is -6. Opposite of -14, +14. Opposite of positive 0.5, -0.5. Okay, one thing that I want you to do is be careful when we start dealing with additive inverse and absolute value. Okay, for instance, and this is why I do this, what is the absolute value of 6? It is still 6. Notice there's a difference here. Okay, there's a difference between this. Opposite and additive inverse, are different than absolute value. Absolute value, remember, is always, always, always what? Positive. Positive, absolutely. All right, so additive inverse is the opposite sign, where absolute value is a distance. It's going to be positive. Awesome. Guess what, ladies and gents? This is the last slide, the last thing you have to write down today. Lucky you. Okay, so what I want you to do is I want you to evaluate each expression. Okay, so you have to evaluate these, A and B. I want you to give these two a shot. We haven't done problems like this, but I think you can figure it out. So I want you to pause now and give these two a shot. Pause now. All right, so if you notice this, these are absolute values. Remember, we are talking about absolute values. Those are positive, right? So if I look at this, -8, the absolute value of -8 is a +8. Absolute value of -5 is going to be a +5. Okay, notice that that sign still stays in the middle. All I have to do first is find the absolute value of -8 and find the absolute value of -5. Then I add them together. Okay, so 8 plus 5, my overall answer is going to be 13. Now, you may be wondering, well, why do I have to find the absolute value first? Remember order of operations, where it says PEMDAS, we have parentheses first. Okay, where we have parentheses, these absolute value symbols are just different types of parentheses. Okay, there are different types of grouping symbols. So you have to do what's inside the grouping symbol first, and then pull it out of the absolute value bars. Okay, so that's going to be very helpful in this one. We have to go, because those absolute value bars are very similar to parentheses, slightly different, but they are very similar. They are a grouping symbol. We have to take 5 minus 6 first. So what is 5 minus 6? -1. Okay, so now I still have these absolute value bars here. It's not just, those blue lines are absolute value. Okay, so now I took 5 minus 6 and I got -1. I had to do what was inside those absolute value bars first. Then I take the absolute value of -1. What's the absolute value of -1? It is going to be a +1. So you actually have to do the operation inside the absolute value first and then solve. Up top, there was no operation what was happening inside, or there wasn't a problem to do inside our absolute value bars. We were just able to find the absolute value of -8 and the absolute value of -5. But in letter B, we had to figure that out, 5 minus 6 first, and then pull them out. Okay, so we're going to talk about this a little bit more tomorrow. I am done for the day. You don't have to hear me talk. Good for you. All right, so I will see you tomorrow. Have a great day. Bye.